Now we will discuss about the symmetrical bidentate type Ma twice and Bc. Here the metal can be cobalt 3, chromium 3, radium 3, rhodium 3 and platinum 4. The monodentate ligand can be nitrate, iodo, bromo, chloro, amine and pyridine. So you just in the case of metal introduce any of these metals and introduce instead of B and C you can use any of this ligand. Okay, next we will pass on to optical isomerism exhibited in coordination compounds. Okay, what is optical isomerism? The enantiomers are defined as the substance which rotates the plane polarized light equally and opposite side. That is, they can get cancelled. That is, one will be in plus form and another one will be in minus form. Okay, and what are that is, the substance is said to be optically active substance, and the substance part which rotates the light towards the right hand side, it is said to be dextro-rotatory and its symbol is small d. And the substance which rotates the plane polarized light to left hand side is said to be levo-rotatory and its symbol is small l. Small l. And conditions for showing the optical activity: it should not have a plane of symmetry. That is, plane of symmetry means the substance should not be equally get cut. That is, the substance should not be cut into two equal half, and the substance should have four different groups. That is asymmetric. That is, the symmetrical same group should not be attached with the central metal. Okay, and there should not be no plane of symmetry. That is the same thing. That is, the substance should not be cut it into equal half. See, in tetrahedral complex there is no plane of symmetry. So in the case of beryllium 2, boron 3 and zinc 2, it exhibits the coordination compound with optical isomers with symmetrical bidentate ligand. So one of the example is bis benzoyl acetonato beryllium 2. See here, the beryllium is linked with the ligand symmetrical bidentate ligand. Oxygen is the donor atom. See, this one is benzoyl group and acetyl acetonato. In the same way in opposite side also. And in the case of square planar, it is also shows the optically active nature. And geometrical isomerism in metal complexes are optically active. For reason is the ligands lie in the same plane and molecule should be asymmetric. That is, the ligands are not same, all are different and can exist in two form, that is D and L form, and they can be the mirror image of each other. See here, if we consider this compound, we just consider this compound and there is no plane of symmetry. That is, the substance cannot be cut it into two equal half. That is, if you are cutting through this side means what will happen? Here this carbon has two hydrogen. Here in this case one hydrogen and one phenyl group. And if you are seeing through this also, this carbon has two methyl group and here one hydrogen and phenyl group. If you are cutting this two into equal half also, it is not possible. Again, this carbon gets different substituent. So it is here in this case it is possible to have the geometrical isomerism because there is no plane of symmetry, so it is comes under optically active. Okay. And optically active isomerism means 6 coordination complex means first one is metal AA3 thrice, that is symmetrical bidentate Ligand. Example is COEN thrice and Cl3 and Cr oxalates thrice and C the chromium and oxalate 3 oxalate ions being as the ligand. See, if you consider this, see, if it has the mirror image means what will happen? Chromium 6 coordination. Here mirror image means just opposite. So what will happen? Here one oxalate ligand, here one oxalate ligand. And in the case of MAA twice and B2 or AA twice or B and BC, that is two monodentate are same here two different monodentate ligand. Here again optical in trans case optical isomerism is not possible, but in case of cis the asymmetric result into DL form. That is in cis form it can has D and L form. And here they have given one example, dichlorobisethylene diamine rhodium 3. See here, rhodium is the central metal atom and chlorine 2 chlorine atoms and bis the ethylene diamine 2 ethylene diamine molecules are there. So again it has the nature of showing optically inactive and it has D and L form. See here in the third case MAA B2C2. So this is bidentate ligand and 4 monodentate ligand means coordination number 6. So here in this case COCl2 ethylene diamine bidentate ligand and 2 amine ligands are there. See here what will happen when the mirror image occurs. COCl, see here Cl NH3 and in ring-like structure because of it is comes under polydentate ligand. Okay, next we will go through the book. We have seen structural isomerism and geometrical isomerism exhibited in 4 coordination number. We have this already. And geometrical isomerism in coordination number 6 complexes. And optical isomerism in tetrahedral and square planar, and optical isomerism in 6 coordination number, in 4 coordination number, tetrahedral and square planar compound, and in 6 coordination number, we are having this compounds. See here, MAA and B2C2, we have discussed this, and complex containing hexadentate ligand, EDTA. See the central metal atom, cobalt, EDTA, ethylene diamine tetraacetate. So ethylene diamine, one acetate is here, one acetate here is, and third one and fourth one. This is ethylene diamine, 1, 2, 3, 4. So tetraacetate, and its mirror image. See this, nitrogen, and this acetate, and this acetate, and third one and fourth one. Okay, listen, go through this, clearly understand and write and see the structures, then only you can be able to write in the exam. So continuously write and see the structures for inorganic chemistry as well as organic chemistry, because if you keep on go through in only means you will not get correct format to write in the exam. So keep on write and see the structures. Thank you, girls.